What up, athletes? Whoop, whoop. All right, let's get into this. This is 1.1, perpendicular bisectors. Whoa, mama, this is good stuff. All right, I'm going to take you right to the lesson material. Boom. Maybe. Let's go backwards now. Sometimes it takes a minute to load up. It just needs a little love, you know what I mean? So this is your warm-up. I've got to have you see it. So go ahead and take a minute. You'll notice on your paper you have a little row up top to write down the coordinate. You're just determining the point that lies midway between each pair of points, A, B, C, D, and all that. Go ahead and do that. Pause this as needed. Again, I'm assuming you're pausing as we go along. Okay, let's do this. So between A and B, I see this point right here. That looks to be the middle, so that's 1, 2, 3. 1, 2, 3. So that's the point 3, 3. I guess I could be doing that like this. 3, 3. Okay. Then we see CD. Where's CD? CD looks like, let's see, 1, 2, 3, about right there. So that's the point -2, 2. -2, right? And then up 2. EF. 1, 2, 3, 4, 5, 6, 7. Oh, so we need to go 3.5. So 1, 2, 3.5 is about right here, which means I'm going -1.5 and then down 1, 2, 3, 4. So -1.5 x direction and -4y. GH. GH, we see that halfway right about here, which is going to be -1, 2, 3, 4, -4, +2, -4, +2. And last but not least, IJ, see that halfway point just visually looks to be right there, which is +2, -2. Now I'm going to write these down on my paper just to make sure we're right, and then I'll show the answers. So I got CD is -4, 2, -4, 2. Is that what I got? No, I got -2, 2. Sorry, -2, 2. I was looking at -2, 2. EF is -1.5, -4. -1.5, -4. GH, that's the -4, 2. -4, 2. And IJ was the 2, -2. There we go. Now I'm going to clear all this. Let's show answers, and look. Boom, we got it right. Okay, so you got some vocab to write down. I'm going to turn to that. And go ahead and write down each of these. I will pause it so you can do so. Want to make sure you have those written down well. Oop, got to do that down. Okay, so I'm assuming you're pausing this. Ready, set, and go. Okay, we're going to go to the next slide. I want you to write down. You got 2 theorems to write down. We'll do the first one, which is the perpendicular bisector theorem. I'm going to have you write down the words and the example. So, right here, what are we saying? If CD, that's this line right here. So let me get some highlighting action out here. Boosh. If CD, right here, boom. That's not dark enough. I like this one better. If C, there we go. If CD is a perpendicular bisector of AB, what does that mean? It means it cuts it exactly in half. Those two sides equal each other. Then we also know, what do we also know? We also know that AC is equal to BC. So if you draw a point from the endpoints of that bisected line to anywhere on the bisector, they will be equidistant. So there we go. That is the theorem. 6.1, pause this, write it down, ready, set, go. The next one is the converse of the perpendicular bisector theorem. This one is going backwards. So now we're saying, hey, if AE, so let me draw this out. Let me just label this out. We've got that AE is equal to BE. So AE is congruent to BE. They're equal to each other. That's why I put that single tick mark to each other. Then E lies on CD. So that point E is on CD. And if that's true, those are equal, then guess what? It must also be bisecting AB, which means AD is equal to BD. That's why we have the two tick marks there, okay? So it's just going at it from a backwards route. Make sure you pause this again, have this written down on your paper provided, and we're going to go to the next question. We're going to go to some questions now. Oh, I got to exit this out. Boom. And let's go. Okay, and what do we see right here? It says find QT. Well, again, we see that QR is equal to SR. That means that RT is a bisector, and guess what that tells us? These two are equal to each other. So I can say 7x minus 3 equals 4x plus 1, and this is just using the perpendicular bisector theorem that says, hey, if RT is a bisector of QS, then it must be that QT is equal to ST. Okay? So let's solve. I'm going to subtract 4x. At the same time, I'm going to add 3. And I get that 3x equals 12. Boom. Or x equals 4. We actually want to find QT, so we need to plug that back in. QT is equal to 7 times 4 minus 3, which is 28 minus 3, or 25. What? Now, we're going to find CD. So I need to find this little section right here. But here's what I know. If AD is equal to AB, then A must lie on CA, and it makes CA a perpendicular bisector of BD, which means BC is equal to CD. It's therefore CD equals 4 because BC equals 4. Look how easy that was. Boosh, we got one more theorem we need to go through. It is the circumcenter theorem, and it is pretty awesome. So, let's talk about that. I've got to cover some. Okay, the last thing we're going to look at is theorem 6.3, the circumcenter theorem. All right, and here's what you need to know about the circumcenter theorem. If I were to find a point P, let's see, the perpendicular bisector of a triangle intersects at a point called the circumcenter. So if I were to draw all the perpendicular bisectors of each of the legs of a triangle, they would meet at a point called the circumcenter. And that circumcenter P, if P is a circumcenter, then we know that PB is equal to PA, which is equal to PC. Okay? And that is important. Because if that's true, then watch what's about to happen. Are you guys ready? Pause this, by the way, write this all down, and then boom, we're going to look over here. I already accidentally worked this out, so I had to cover it up. But if I know that's true, then I know that HE is equal to HF, right? So HE is equal to HF, which means this is 4.85. Boom. That's important to know. And this is 2.8, because watch what I can do now. It says I need to find FL if H is the center of triangle EFG. EH is 4.85 and LH is 2.28. Well, I wanted to mark that down because if I were to draw this triangle, not very well, but I'm going to draw it nonetheless. Let's see, the 90 degrees would be at L. We know that LH is 2.28, right? LH is 2.28, and I know that HF is 4.85. Remember Mr. Pythagorean theorem? If this is side A, this is side B, this is side C. And we know that A squared plus B squared equals C squared. Well, I need to find B. So what can I do? Watch this. Minus A squared minus A squared. I know that B squared equals C squared minus A squared. Square root both sides, and I get that B equals the square root of C squared minus A squared. So to find side B, all I have to do is say, all right, this is equal to the square root of c squared, which is 4.85 squared, minus 2.28 squared. And I'm not going to do that by hand. I hope that's okay with you. I'm going to take a calculator. So let's do that. I'm going to have a clear second function square root. And don't have to use, other than that one parenthesis to show that everything's under the radical, nothing else, 4.85 x squared minus 2.28 squared. Close it off, and what do I get? Boom, about 4.28. And I'm going to round to the hundreds because everything else is rounded to the hundreds. So 4.28 is approximately 4.28. And boom, we now know that FL equals 4.28. There we go, guys. We found it, easy peasy lemon squeezy, using the in-center theorem and everything we know. This is just an introduction to some triangle properties that we're going to be looking at, theorems and postulates going forward. With that said, peace out.